All right, so kind of the next set of notes in our probability unit is something called simple probability, and it's kind of what you think of when you think of probability for the most part. So some vocab at the beginning here, okay? Something called a sample space. A sample space is the set of all possible outcomes of a scenario, okay? So for example, we write it kind of like a set. When we talk about set theory, okay, it's written a lot like a set is. So the sample space of rolling a six-sided number cube, okay, is you can roll a 1, a 2, a 3, a 4, a 5, or a 6. So it's the set of all outcomes. So those are the outcomes. All right, next is what is probability? Okay, the formal definition of probability, okay, I say formal because I dumbed it down a little bit because we don't like the words. The likelihood an event will occur. Okay, so the likelihood of something happening is probability. That's what it is. And then last, okay, we can write probability in different ways. We can write it as a fraction, as a decimal, or as a percent. When we did deal or no deal, we wrote it as a percent. We used a fraction to get that percent, but percent kind of made more sense to us. So if we do probability of, for example, A, okay, that's how we would write it. So P of whatever you're doing, okay? So P of A is how you write it. P stands for probability. That's just kind of a way that we'll write probability. Nothing super special. Any questions for me? Okay. I know some people are slow right now. I'll give you a second. All right, we're going to go through some scenarios here, some different questions. Okay, so number one, rolling a 2 on a six-sided number cube, basically rolling a 2 on a dice. Okay, how many times can you? How many options are there to roll a 2 on one die? How many sides have a 2 on a regular die? One, right? There's one, 2 on a die, and then we're going to roll it. There's 6 sides. Okay, so 1 out of 6 is your chance of rolling a 2. What about rolling an even number on a six-sided number cube? How many even numbers are on a six-sided die? 2, 4, and 6, right? So that would be 3 out of what? 6. Okay, we're going to simplify that to 1/2. All right, flipping a fair coin and landing on heads. What does a fair coin mean? Right, one side is heads, one side is tails. So you know for sure it's head and tails. Okay, what's the probability it'll land on heads? 1 out of 2, right? There's 2 options. One side is heads. So 1 out of 2. Okay, we could write that as a 50% chance. So again, we can do it as a fraction or a percent. What about selecting a green marble from a bag containing 3 red, 4 green, and 5 blue marbles? Okay, so he says 1/4. How did you get to 1/4? Say it again. 4 out of 12. So how did you get 12? You add them all together. 3 plus 4 plus 5 is 12, right? And it says a green marble. Well, there's 4 green. So 4 out of 12 is the same thing as 1 out of 3. Questions for me? Okay, that's, in a sense, that's just really simple probability. That's what it is, okay? So when you think of probability, this is more times than not what you think of, okay? We're going to toss in some Venn diagrams. So, is it Lila? I think it's supposed to be Lila. Is spinning a spinner with sections numbered 1 to 8. And she's recording the results. Event A is spinning an odd number. Event B is spinning a number greater than 2. So we need to decide where do they intersect, okay? What's only in A, what's only in B, okay? So if she spends A1, which section is that going to go in, A or B or both? A is an odd number, right? So it's definitely going to go in A. Will it go in B? No, because it's not bigger than 2. So we're going to put 1 in there. Okay, if she rolls a 2, is that going to go in A? No. Is that going to go in B? Is 2 greater than 2? It's equal to 2, but it's not greater than 2. So actually, that one has to go outside, because that doesn't match A or B. What about 3? Is 3 an odd number? Yes. Okay, is 3 greater than 2? Yes. So where's it going to go? If it's both of them, it's going to go in the middle. All right, is 4 an odd number? No. Is 4 greater than 2? Yes. So where's it going to go? All right, 5 is an odd number. Is it greater than 2? Yep. It's going to go in the middle. 6 is not odd, but it is greater than 2. So put 6 over here. 7 is odd, and it is greater than 2, so it's going to go in the middle. And then 8 is not odd, and it is greater than 2, so 8 will go over here. Any questions for me on filling in a Venn diagram like that? Okay. All right, now this is a little bit different, okay? This section I'm not super fond of, if I'm going to be honest with you, but that's okay. All right, so it says create a second Venn diagram to show the probability in each section, okay? So if we look at what we had on the other page, okay, how many total outcomes do we have in section A? How many total outcomes do we have in just section A? 4, because these 3 are also in section A. You with me on that? So there's a total of 4. Out of how many? How many total options are there? 8, right? Because we went all the way from 1 to 8. So there's 4 in section A out of a total of 8. What's that probability? That, oh wait. Oh, I was wrong. 8 was 3. They only wanted 1. I forgot. Okay, so probability is only section A. So think of kind of like the moon. Don't include this guy. Okay, so that would be 1 out of 8. Now, if we talk about the center section, that's how many out of 8? How many numbers are in here? 3. Okay, so that probability is 3 out of 8. How many are only in B, not including this guy? 3. Okay, and what about our outside? 1 out of 8. Okay, so we're going to answer those guys on the left-hand side here. So remember, what does P stand for? Probability. So the probability of getting something that's inside of A, what would it be? 1 out of 8. Okay, probability of B, 3 out of 8. Okay, probability of the intersection of A and B. Where can we find the intersection of A and B? Yes, that's that middle section right here. That's 3 out of 8. Okay, here's a new one. The union of A and B. What's the union? Both of them together. Okay, so what is our total probability for that? Say it louder.
Half. 40.
Not half. How many numbers are in here? 7 numbers, right? There's 1 on the outside. So the union is all of them together, right? So that's going to be 7 out of 8. Do you remember that bar over top means? The opposite, okay? So if we take the union of A and B up here, what's the opposite of 7 over 8, or what's left? 1 out of 8, okay? Now, let me put it a little bit further. What number is that 1 out of 8? 2. Okay. 2 didn't fit in either of those parts, so it doesn't fit in that group. Questions for me on that? All right. Let's keep moving. You're going to have more scenarios in your cylinder diagrams like that. All right, Miguel is going to select an outfit from 2 different shirts. All right, so he has t-shirts that are tan and red. Okay, 2 different pairs of shorts, gray and khaki, and 3 pairs of socks, black, navy, and white. Draw a tree diagram to represent all possible outfits. So where do we start? Where do we start? T-shirts. Okay, so he can do tan or red. Now, for whatever he chooses for a t-shirt, what's his next option? His shorts, gray or khaki. Once he chooses his shorts, then he can choose what? Socks. Black, navy, white. Okay, there's your tree diagram. That was a pretty short one. Mine's not the most beautiful, but that's okay. All right, if each outfit has an equal probability of being chosen, what is the probability that Miguel will select a red t-shirt, khaki shorts, and white socks? Okay, so let's think about this. How many total t-shirt options are there? If we go back, how many total t-shirt options are there? 2. Okay, 2 total t-shirt options. So if he chooses a red shirt, that's 1 out of 2 options. You track with me on that? Okay. How many total short options are there? How many different color shorts does he have? 2. Okay, so if he chooses khaki, that's another 1 out of 2. And then how many sock options are there? 3. So white socks is a 1 out of 3 option. Now we just multiply those. It's a lot like that fundamental counting principle. But here, you kind of take it one step further and you're given specifics. So you have to figure that out. Okay? So if we multiply the top, what are we going to get? What if we multiply the bottom? 12. So he has a 1 out of 12 chance of choosing that exact outfit. Because there's a lot of different options. Questions for me on number 8? Okay. What is the probability that Miguel will select a tan t-shirt and gray shorts as part of his outfit? Does it ask about socks? No. Okay. So if we think just a tan t-shirt, well, we said if he chooses one of the colored t-shirts, that's like 1 out of 2. If he chooses gray shorts, that's another 1 out of 2. Okay, multiply them. He has a 25% chance, or a 1/4 option, of selecting a tan t-shirt and gray shorts. May not necessarily match. All right, what is the probability that he will select gray shorts as part of his outfit? Well, how many short options are there? 2, right? That's just 1 out of 2. Okay, gray is one of those colors. It's just 1/2. So sometimes you'll be asked to do all the options. Sometimes you maybe do only a couple of the options. But in a sense, you just multiply them. Okay? If there's only one option, then you don't have to multiply. The table below shows the results of a survey of a students in grades 9, 10, 11, and 12. And they were asked if they prefer rock music or rap music. So if we look, how many total students are there in ninth grade? 50, because we take 15 plus 35. How many total students in 10th grade? Yep, 50. Same for 11. Oh, same for 12. Okay, so if we look at totals, how many total students are there? 200, right? 50 plus 50 plus 50 plus 50, 200 students total. Now, let's see how many really like rock music. I don't know if I can do this with my head. Give it a shot. Oh, that would be 10, 18, 98, 8. 11, 12, 22, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 102. Okay. All right, so obviously more like rap than rock. All right, what is the chance that a student chosen at random is a ninth grade student who prefers rock music? Ooh, okay, gotta break it down. So ninth grade student. Okay, how many ninth grade students are there? 50. Out of 200, right? So ninth graders is 50 out of 200. Okay, can we break that down a little bit? What's 50 out of 200? 1/4, okay. Okay, how many students prefer rock music? Huh? 98. Out of how many? 200. Okay, now I don't know if we can break that down. I'm going to get my calculator. Sure we can, because we're even. Doesn't break down all that much. Okay, now that we have those two, okay, we can just multiply those. If I multiply them, okay, I get 0.12, okay, which is about 12%. Okay, we could write it as a fraction, but it's a very fraction. All right, what is the chance that a student chosen at random is a 10th grade student who prefers rap music? So how many students are 10th graders? 50 out of 200, which is the same thing as 1/4. Okay, and then how many total prefer rap music? Say that again. 102. So 102 out of 200. Okay, so if we multiply those, okay, get like 12 point. It's almost 13%. We'll say 12.75%.
So why would we use the 24?
We do like 24 divided by 50.
No, I don't know.
You could, but that's not the same. Maybe that's the way they want you to do it. Let's look. Oh, they don't want to do it either of our ways. Well, I guess okay. All right, so I mean, and I think that's what's hard about probabilities. There's different ways of thinking about it. On the answer key, which this was from not me, the ninth grader who prefers rock music, here's what they're saying. It's 15 out of a total of 200. Okay, so let's look at it that way. Maybe that's a little bit easier than what we were doing. That's fine. I like it. I like making things simpler. Okay, so let's rewind. So if we look at how many total ninth graders, right, and we break it down to rock, well, there's only 15 out of 200. Because if you take total students, okay, 15 of them are in ninth grade and they like rock music. It might be a little bit easier for us to wrap our heads around. So 15 divided by 200, 7.5%. Okay, or 0.07 if you want to write it as this. So let's redo number 12. Okay, so if we're going to go by this method, okay, it's 10th grade who prefer rap music. So how many in 10th grade prefer rap? 24. So then what would be our fraction? 24 over 200. And that's 12%. All right, number 13. What is the probability that a randomly selected student prefers rock music? Woo! Okay, we gotta think about this one. So randomly selected student. So does it matter their grade? No, it doesn't. Did it say rock or rap? Rock. Okay. So how many students like rock? 98 out of how many students? 200. So you do 98 out of 200. That's almost half. 49%. All right, what is the probability that a 11th grade student chosen at random prefers rap music? All right, how many 11th graders like rap? $25. So 25 out of 200 is. What did I miss? Oh yeah. At random. Okay, so they want it out of. Yep. I need to see that. I need to have my own paper here. So 25 out of 50. Yep. So that is 50%. 50% chance. Maybe we'll just pull up my paper here. Make it easy something to do that. All right, number 15. What is the chance that a randomly selected 12th grade prefers rock music? And there are 32. Yep. 32 out of 50. And that percentage, 64%. All right, I think the rest is practice. Okay, so we will. 6 minutes. Okay, so you have about 6 minutes to work on that. We'll talk about it at the beginning of the period tomorrow. And tomorrow we're going to do an activity. Not as fun as Deal or No Deal, but it'll be fun.